AI tools. We have Raj today who will be making presentation on the work he has done on Lidar scanning. So this is apart from that general idea about what tools are used for heritage conservation. So we have only these two lectures scheduled today. After that we'll have the validity. So all certificate is unfortunately Ramakar sir has also done work on Lidar scanning, but he was unable to come. He got some emergency work. He has gone. He is not in Patna. Okay, so we all know what cultural heritage is. Now that 4 days have passed, so do we know what cultural heritage is? What is cultural heritage? It's all given over here, but what is your impression about cultural heritage? It's a legacy. It's a heritage or remains of the past, which gives us our identity and it gives a sense of history to us. So the legacy of physical artifacts and tangible attributes inherited from past generations, maintained in the present and bestowed upon future generations. So this will include, heritage includes anything, whether you can touch, feel, see, or just folklore, maybe some dance form, art form, festivals, any kind of worship. These are all our culture inherited. So basically everything encompasses heritage. So there is tangible heritage and intangible heritage. We have already discussed all these things. So basically monuments, buildings, works of art, landscapes, traditions and knowledge, all are that have cultural, historical or artistic significance. They are known as cultural heritage. So now what is conservation? Now basically I have come up with classroom teaching, theoretical, and some of these then we go to the high-end tools and techniques for heritage conservation. So what is conservation? It's basically preservation of historical knowledge, promotion of cultural diversity and potential to boost local economy through tourism. As you know, tourism has a multiplier effect on the economy. So people come for one thing, but there are allied or associated industries which also have a meaningful financial gain due to tourism. So important items that are to be conserved include ancient monuments, traditions, crafts, historical buildings, intangible cultural practices such as festivals and oral traditions. Heritage is also included in, we have sustainable development goals. How many are there? 17. So goal number 11 has target number 4. Each goal has several targets. So goal number 11 is about cities basically. So sustainable cities and communities, that is goal number 11 in SDG. And target 4 is about cultural heritage. So the name of the target is protect the world's cultural and natural heritage. So exactly what UNESCO is doing. Now what are the methods of heritage conservation? So basically there are lots of confusion as to what is conservation, what is preservation, what's the difference. So this simplifies the whole thing. You have basically heritage conservation. Now that may have different ways of protecting heritage. So we have preservation, we have restoration and reconstruction. These are all methods of heritage conservation. Even simple maintenance of heritage is heritage conservation, because we just preserve, we just maintain it, and that is heritage conservation. So preservation involves maintaining the existing condition of heritage sites and artifacts without significant alteration. So when we don't alter, whatever the state of the remains is, we retain it as such. That is preservation, or we can say maintenance. Now restoration and reconstruction. So what is your idea of restoration and reconstruction? What is the difference basically? Restoration and reconstruction, any idea?
reconstruction we would means construct it all again.
All over again.
And we should have some historical evidences
Yes.
which prove that this is the picture of the place which was there in history. So
Yes. And restoration is like whatever is remaining, we just construct out of this. Now there is one fundamental difference between restoration and reconstruction. We don't use any new material in restoration. So either we use the debris fallen around, or we try to find salvaged materials from other monuments which are in worse condition, which are not worthy of protection. So if we have some materials which are similar to the one we are restoring, then we can carry those materials for restoration of this one. Okay, so the difference is this: restoration, we can use this debris fallen, or we can use salvage materials from other similar monuments, so that its historical context does not get damaged. And reconstruction is where we can use new materials. So that is the basic difference. Now again, preservation is, there are three fundamental ways of preserving: maintenance, repair involving restoration, and repair involving reconstruction. Again the same things. So preservation includes these three. So the definitions are all here. If you want, I can pass on this to the group, this presentation. In fact, all the presentations, can we do that? शिवम, वो सुप्रिया के लैपटॉप में भी है, वो है कार सर का जो presentation है. So here we have restoration. Now you can see it may include recycled materials salvaged from other places. So basically restoration is defined as returning a place to a known earlier state by removing accretions or by reassembling existing elements without the introduction of new materials. So restoration, we don't introduce any new materials in restoration, but in reconstruction we introduce new materials. So that is the basic difference between the two. So most important restoration is, can you recall this? Who knows what this is? Notre Dame. France, Paris. The Seine River, along which Paris is located, there is an island in between the river. So on that island, this cathedral is located. It was damaged due to fire. So everything was damaged, but local people had a huge role in protecting whatever artifacts were there. So they made a human chain, and they carried one by one, passed on to the next one and to the next one, and that is how the artifacts within the cathedral were protected. Whatever was made from bamboo or wood or any such material which could be damaged due to fire, that was gutted. You can see the upper part of that spire fell. But then this was reconstructed. However, there is one important thing for any kind of restoration or reconstruction. What is that? I mean, किसी की मूर्ति भी बनाते हैं, तो we need something. So the original person has to have either a photograph or something. So our students made some portraits in the inaugural to give away all to the guests who were invited. Now those portraits could not be made without a photograph. At least a photograph should be given to them, then only they can make a portrait. Similarly, if you have to restore or reconstruct any building, it has to have a documentation, prior documentation, which should include all the dimensions and details of what type of architectural features are present. Only then it can be restored to its original shape. So for that, prior documentation is most essential. Now this Notre Dame Cathedral you may find in many history books, but you will find a picture, some basic dimensions, nothing much in detail. So it wouldn't have been reconstructed unless a gaming company who was making games, these games have certain monuments and then you go around finding people or whatever. So one such gaming company had its documentation because it had to make 3D views of this for that gaming to continue. So they contacted that gaming company, and that company came up with all the drawings and details, whatever it had done. And that was the basis for its reconstruction. So it is important in modern times. This is a huge example of how reconstruction or restoration can be done. So all the artifacts that were protected nearby were then just pronounced. Now the basic definitions are over. Now we will see the high-end tools or digital technologies. This is the era of sensors and IoTs and decision-making technologies, which not only capture or gather data and organize, store and calculate, but they also take decisions on behalf of humans. So there is no need for human intervention. Some such technologies are incorporated. So we have some digital technologies for heritage management and conservation also. These are some of the wonderful technologies because we have done some things on photogrammetry. I have a research scholar who is doing something on 3D scanning using laser technology, Lidar technology she's using. So the first and foremost technology is geographical information system. As you know, whatever has to be remotely sensed, any data that we want or need from remote sensing, geographical information system is the one. It is satellites which have several spectrums, and those spectrums emit radiation. The radiations are reflected and captured, and those are the images that are remotely sensed, which are made use of for various kinds. You can have your land cover details, you can have underground features known, like sir showed you a map as to which district what is available. Now we do not need physical movement, we can just scan using satellites and the spectral colors, so infrared, ultraviolet, or different kinds of radiations can be used for taking satellite images, and those satellite images can be manipulated or maneuvered to get whatever information we want. So geographical information system has a huge role in digital, in conservation and preservation also. The most important thing is you have to have monuments to preserve and protect. So whatever is known, there are many things apart from what is already known. So how do you detect that? There GIS and remote sensing has a huge role. So you can detect, there are many scientists and researchers who are actually doing research work based on satellite images, and they are looking for some settlement or some monument which may be trapped underground, part of it would be visible or even that may not be visible. So that is there is a huge role of geographical information system. That you have artificial intelligence. Now artificial intelligence has been created by humans, so that is an intelligent system again for taking care of your heritage buildings. Then you have 3D scanning and photogrammetry. Here we use either photographs which are overlapping, and then we assemble them through softwares, and you get 3D models generated for all these heritage buildings in any object. So it is usually used in advertisement, advertising industry, and of course heritage management. Then you have virtual reality and augmented reality. So this is kind of a blessing for people who do not want to move around to various places to see the monuments. So your virtual reality can be created on the internet through any means, photography, photogrammetry, whatever, and then people can just view them on their own, sitting at their home on their own devices. So That is one, and then augmented reality is like the virtual reality is has some real pictures, some are computer generated, and others whatever is man-made that can be augmented, and then together these can be viewed. Or even at sites when you go. So there you can see the buildings, and then you have virtual information also that can be collected. So that is your augmented reality. Now these are highly important for tourists basically. Some who are visiting the place, and even if you are not visiting the place, is virtual reality which makes it possible to have an experience of as a tourist. Then you have mobile applications and digital platforms. Now these are the objects where you see those created using virtual reality and augmented reality. Then you have heritage building information modeling. Now these are, when you do a 3D scanning of a building, then you need some software to process them and create the 3D views of those. So your BIM, normally architecture students must be knowing what is building information modeling. The heritage building information modeling is about heritage buildings, the buildings that are existing, so you create models of those heritage buildings, and those are HBIMs. Then you have cloud computing and digital repositories. These are basically places where you store data, you can calculate, compute, and the data is retained there in the systematic way. Because manually, if you collect such data and retain it somewhere, it will take volume, a huge volume. So these cloud systems, they provide a platform for sharing. Otherwise, you have storage in your mobiles, but they are limited. So if you use cloud, there is unlimited data, and it's substantial, so anything you want to store, that can be done. Then we have blockchain technology, which basically protects your breach of your data that you have. So these are some of the usefulnesses that have been shown. For example, GIS. Now this is one example in Poland. The first 4 pictures you see, that is one example of use of GIS in mapping, and at a place in Poland. Where the first picture on the left hand side, that shows you the density of all the heritage areas located within the city. Then you have people who have certain areas for which they have a positive notion. For certain areas they have not so positive, or you can say negative notion. So the green and the red, they are basically surveys from people, what kind of impression they have for the heritage, whether they have a positive notion or a negative notion, and then the heritage areas actually are created, located with having, which are well known or which are more popular among the local population. So this is one way of coming up with, I mean, if you have some ideas, you are doing some research, or you have some projects where certain information is required, that can be taken up. So the second picture is of a heritage bylaws which were prepared by us. This is Sagar, if you have heard, it is in Assam. It's a district as well as the district headquarters. That is also known as Sagar. So there is a lake which was excavated with a square in plan called Joy Sagar Lake. Now there are monuments around those lakes. It is a custom in that area. Create a lake, and then they create 3 types of temples around that lake. Those are known as Dole temples of Assam. So Shiva Dole, Vishnu Dole, and Devi Dole. Devi Dole is for Durga. So here you can see the 3 monuments that are the main ones around the temple are these. This is Vishnu Dole, number 4. Number 3 is Shiv Dole, and number 2 is Devi Dole. In number 5 and number 1, they are additional monuments of national importance. So we had been given, or we had been asked to prepare heritage bylaws for temple number 3. This is Shiva Dole. Shiv Dole of Joy Sagar tank. So there are several tanks and there are several Shiv Dole, but the tank name is unique. So Joy Sagar tank के पास जो Shiv Dole था. Now what we did, because there were other monuments in its vicinity, heritage bylaws are basically prepared for 100 meter and 300 meter buffer. So पूरा total 300 होता है, एक बीच में line होता है, buffer होता है 100 meters से. But many such monuments were there जिनका 300 meters का buffer intersect कर रहा था. So first we found out all the state protected monuments in the vicinity, then all the nationally protected monuments in vicinity, and then we created buffers for all. जिनका intersect कर रहा था वो सब इसमें दिया गया है. जो नहीं intersect कर रहा था, it doesn't matter, because when the heritage bylaws are implemented, they should be implemented in conjunction with all the others that are falling within or having their 300 meter buffer intersecting, or even the 100 meter buffer intersecting. But here we don't have any temple where 100 meters buffer was intersecting, so this is it. So if we see in GIS related to heritage, it is Italy which has the largest contribution of in the field of GIS and heritage. Now you have historical data analysis. This can be done using artificial intelligence and machine learning. So I have given some examples of how historical data can be analyzed, how predictive modeling can be determined, and how predictive analysis modeling, what it consists of. So you can have classification modeling, clustering modeling, forecast modeling, outlier modeling. There are different types of modeling can be done, modeling and simulations that can be done using machine learning. So what they do is, if you have certain predictions as to a heritage building which may get damaged in certain number of years, how it will be damaged, if you want to know a hypothetical scenario that will actually happen. So in spite of getting that done in reality, it is done using models. So that model, those kind of models can be generated using artificial intelligence and machine learning. Then there are 3D scanning and photogrammetry. You can have various ways in which they can be done. Now here the simplest is photogrammetry. What you do is you take overlapping photographs. So एक छोटे से भी object का maybe 700 or 600, 500 photographs you take by just moving a bit, so that they overlap. Then you put it in a software and it will generate 3D models for you. Because we have done documentation of Nepali Mandir at Hajipur. That was given to us by Directorate of Archaeology. But at that time we were not very conversant with photogrammetry, so we did everything manually. So we brought the whole measurement of each and every part of that temple, somehow, sometimes simply measuring, sometimes climbing to the tops, and our students have helped a great deal in this. So we did photogrammetry, and then we had a workshop in which actual people who are experts in photogrammetry, they had come and given lectures. So many of our students and faculty actually attended those and was very painful. With this photogrammetry and laser scanning or Lidar, they actually don't just produce a 3D model, they also come up with whatever damages your building has. Even if there are fine cracks, those can also be detected using Lidar survey. Lidar scanning basically. So this is laser beams which are जैसे photographs होता है, now you take photographs using laser light. So they are more accurate, very high end, and they create a model of the building. You can do all kinds of documentation using the information that is provided to you when you use a Lidar. Although there is a cost factor involved, Lidars are very expensive, and therefore you have less expensive लेकिन वो छोटे छोटे एरियाज को स्कैन करेगा. If you want to scan bigger areas, you should have instruments that scan larger areas. But those instruments are actually not very cost effective. So, yes, photogrammetry, which is still used especially for students and researchers, we use photogrammetry. There are institutes where you have Lidar available, but those are few in numbers. Not all institutes can have that. Even we are thinking of what we'll purchase when we get some kind of project where such documentation is required, or if we get lots of monuments to have documented, for documentation. Hello. Light scanning is through different types of light patterns into objects, and those lights are reflected, and it gives rise to all the deformations and patterns. So basically, all these kinds of scanning, thermal images now, if you have thermal cameras which can capture heat radiation coming from various areas in the building, that can also give you an idea about the cracks and crevices or whatever damages are in existence in a building. So the first image is thermal scanning, the second one and the third one, they are the same site. Basically it's Humpty. So these are the laser scannings of these two images. You know how this can be scanned is there are three different, okay, I have slides which I can explain. So you have virtual reality and augmented reality. So these are some of the examples of how basically you find more of mixed realities these days. You don't find truly virtual reality or truly augmented reality. It's basically mixed reality. You can have both the simulation environments and the real thing in front of you together. So the elements of both are run together. Now there are mobile applications and digital platforms. These are where you can see all your 3D models that are generated in historic buildings. Basically, mobile apps can also help get information from people. It can crowdsource and get information for a particular monument. Then you have historical building information modeling, HBIM, which is an extension of BIM. And all your laser scan data and photogrammetry and all digital images are actually processed using historical building information modeling. So some of the examples are given. You can see here you have a normal photograph of the building, and this one is a 3D model of the same building that is generated using HBIM. This is another model of a building. Blockchain, as you know, they prevent any data breach basically, and cloud computing and digital repositories are where all your data, which is in a huge number and not possible manually, those are protected. Now, LiDAR scanning can be in three ways. First one is at ground level. I think Varadraj will explain you better because he has had a first-hand experience which we don't have. This is just a theoretical information that we are providing, so he'll explain you better. So there are three different levels at which your LiDAR scanning can be done. One is at ground level, the ground unit. Another one can be mounted on a drone and can fly above, so it can take aerial pictures and pictures from the sides of the monument. And then you have satellites where such LiDAR instruments are mounted, and you can have information available from all these three levels, sometimes just two or simply one level also. So basically these are laser lights that go to a building in pulses, and as they are reflected. They measure the time it takes to bounce back, and that gives you an accurate measurement. So this is the most accurate among all the different ways in which your images and information, basically dimensions of an existing building, is recorded. So this is the most accurate one. These are some of the ways in which data are acquired. So basically Lidar is light detection or ranging. It is laser imaging, detection and ranging. So Bharadwaj, can we have your presentation now?
Right in front of IIT Kharagpur, there is this is the campus of IIT Kharagpur, and this particular spine is right in front of IIT Kharagpur. So we began with an understanding of this whole ward. The whole class was divided into two groups, and IIT Kharagpur is in ward 30 and ward 29 and 28 were used for the assignment. So we went into these two wards, divided into two groups, and we first completed the land use survey. So this is primarily a slum, and some slums were located here, and subsequently all the other land uses were understood, and other such surveys like transportation surveys, household surveys, and that gave us an understanding of the area. So this is in West Bengal, Paschim Medinipur, West Medinipur, and in that Medinipur. And so
it's written as Medinipur, but it's pronounced as
people were called as Medinipur. So we began with an understanding of the area, and then subsequently proposed a land use map. And this was a long exercise, but the point where Lidar came into the picture was next. So this was the sequence of activity. We first understood the land use, the problems in the area, and in that process what we did was, first part was the stakeholder consultation, where we went to different locations in the locality, and we wanted to understand the problems that were being faced by people. As we were taught, the planning is data driven, and so that was the second consultation, and then we met the ward councillor, and then subsequently at the fourth stage we went into the Lidar survey. So this here is the Lidar we use. This is a Leica BLK 360. This is supposed to cover 45 meter of radius around its point. So in the earlier slide, this was the whole ward, and this particular area was our concern. We narrowed it down to this particular spine for development and whatever design proposals we will have in mind. And this particular spine was named as the action area plan. We were to propose an action area plan for this area, and this is the particular spine that I am talking about. This is right in front of IIT Kharagpur. So you have to understand is what these two lines are. These two lines are railway lines, and this land is not privately owned land. This is government land, and all of this is basically a disputed ownership. There is a tussle going on between the local municipality and the railway administration. The railway wants to remove all these buildings from here, and the local municipality is kind of obstructing that process. So these were the circumstances under which we arrived, and we kind of wanted to understand how to make a proposal which is in line with this tussle between the municipality and the railway. So this land is conflicted land basically. This is what we understood from the survey and consultation with the ward council, that this land is, these two are railway lines. This map is as per Amrut level 2, and these two lines are the railway lines, and this kind of bisects this land in between. So this is disputed land. There is a tussle going on between the municipality and the railway, and ownership is not clearly defined. People there claim that this is our land, and sometimes the railway posts notice that evacuate, and then municipality will step in, and so there is a tussle going on. So this was the picture in which we arrived to make a proposal. And we have to keep in mind that our proposals should be in line with the existing circumstances. That was a part of the assignment. So we began with this survey to understand the spatial taxonomy. Primarily the survey came in after we decided this stretch. This stretch was finalized based on the critical requirements of this area. So this ward is a huge ward. We wanted to narrow down on one particular space where we could propose where our interventions would bring maximum return on investment. So this was the particular stretch right in front of IT Kharagpur, which would bring the maximum return on investment, because students from college would swarm into this place after exams or at night. So this was the stretch chosen, and there was this other group which chose this stretch, which was the slum development. So then we enter into the Lidar survey. This Lidar survey is like a BLT 360. It is supposed to have a radius of coverage of around 45 meters. So let's say the Lidar is placed here, it will cover around 45 meters of radius, as in everything that it basically is spreading a sheet, and all that comes in that sheet will be covered and captured in terms of point cloud. So as ma'am was mentioning, there are several mechanisms in which this can be done. There is one way that's aerial Lidar, and this is ground based Lidar. So this is not, this has to be stationary, it can't be in motion while we are doing that survey. This has to be at a point, located at a point, and then it will capture the entire area around the environment. So this stretch which I showed in the previous slide, this stretch was particularly what we were trying to capture with the Lidar. So we chose 13 station points based on the radius of coverage, and subsequently we faced issues and challenges in modeling this area, but then for now we are in the understanding that this will be enough for all the data that we need for this particular study. So we started from here, this was the first point, second, third, and 13 points like this. And we acquired data to an extent which was enough. But now when so this point, the data format in which the data is collected is point clouds. So this is a surface, but a point cloud is a very small point which is vast in number, and Lidar is basically collecting all the points, it's populating those points. The next stage is preparing this. So this is the final product, but coming to this point involves successive stages. So first we have, so these were the three softwares which we used for creating that final mesh. So first we use this Cyclone 360. This is the software where the point clouds will be populated and categorized. Now what happens is, once, let's say we use these 13 points to create the survey, and during the survey, as and when we move, the app is also recording our movement and locations. But when we go back to the computer to kind of stitch it all together, we find that the locations are not accurate. They are not in sequence, they are not accurate. So it creates linkages basically. The software Cyclone 360 creates linkages between the points. So the linkage was not accurate. So then we had to kind of correct that. And that process happened in this software Cyclone 360. So this was the first stage of the proposal where we were kind of correcting the data. That became a mess in and of its own. So after correcting the sequence of data, we had to calibrate. So what happens is, the first Lidar point and the second Lidar point has to have an overlap, a minimum of 90% of overlap, which is required, mandated by the software. If it does not have that overlap, the model will not be created. That is one of the critical challenges. So we need to find that overlap, and of course we can prepare a model, but that will not be up to the mark, and which is what happens.
It's kind of the same as photogrammetry. We have to have at least 60% overlap. So again, here also you have to have that overlap. That was my question, whether you have overlaps or you just have individual locations and then you survey that.
Yes.
So you have to have overlap.
Yes.
And here you have to have 90% overlap.
Yes. It's mandatory that software, and of course we can export a model, but that will not be useful to the extent that we need it to be. So the second stage after finding the overlap and calibration was Autodesk Recap Pro. So we wanted to create a mesh from the point cloud. Point cloud in and of itself can't be used for analysis. We need to have a mesh, a surface from that point cloud, so that we can then create models which will be predictive in nature and be used for our proposals. So then we used Autodesk Recap Pro. We first struggled with this Cyclone 360, but then it was not very productive. So then we shifted to Autodesk Recap Pro after a lot of research, and ultimately we modeled all of that in Rhino. Now in Recap Pro we created meshes, and meshes can be of different quality and variety.
So the question is, what is a mesh?
Yes, ma'am. So Lidar, let's say we did a survey Lidar. Lidar is placed at a station point, and what it will do is it will send out signals and it will calculate the distance and it will create a point. Points are created, multiple thousands of points are created in all that it sees. So this Lidar particularly, it has a coverage of 360 degree horizontally and 300 degrees vertically. It cannot cover the entire 360 degree vertically. So a black circle will be observed at the bottom, which I'll show you in the, actually it's visible here as well. So this particular circle is not covered by Lidar. This is a point cloud basically. So what happens is Lidar sends out signals and it creates points. Points are created, but then point can't be used for analysis. We need a surface for analysis. Let's say a flood analysis has to be done or a slope analysis has to be done. We need a surface for analysis. So point in and of itself is not enough. Now mesh is the triangles created between points. So we'll connect three closest points and that will become a mesh. And that is the process which happens in Autodesk Recap Pro, the second software which. So this particular slide highlights the resolution of the mesh. Now what happens is in Lidar data collection, data acquisition, since it's not, so one of the learnings from this experiment was Lidar is not the best for outdoor areas. And particularly this one, because this is meant for small scale details or temple, like you said, reconstruction analysis, etc. So this was one of the major links, but what happened was the density of point cloud was not enough. We needed a more dense point cloud to be able to prepare models that would help us bring simulations into the picture. But then what happened was, let's say, have a look at this model. So this particular mesh is based on points which were 0.05 mm apart. That is the level of accuracy, 1 to 2 mm. So one important note here would be, why is Lidar so relevant for us, in particularly urban revitalization? Data collected from satellites would be at best 30 meter resolution, but then this data is down to 1 to 2 millimeters, so that's much more than what we hope for. So these points particularly were 1 to 2 meter apart. That's a very small amount of points which we could capture that were 1 to 2 millimeters apart, and then subsequently, so the mesh created here would be much more fine in the nature of detail that we achieve here, because the points here are at much greater distance. At maybe this was 10 millimeters and this was 100 millimeters, so that's almost 1 centimeter. The resolution kind of goes up. So this is the same location but 3 different slides. The only difference here is the point cloud. The point cloud which are close are in this particular slide, and the point clouds as they go distant, they are subsequently smaller, bigger and bigger in size, but the details keep going down as it will be more. So this was the second stage of the model preparation, where we wanted to model the whole area, and particularly this. So the stretch which I was trying to show in the map is this stretch. This is what we modeled, and so this is the final product from Rhino. The first thing we did was point cloud classification, the alignment of Lidar. We sequenced the Lidar in how we had the survey, and then the second stage was point cloud classification, where in Recap Pro we categorized the point clouds into lands, trees, buildings, and there was a flyover right next to this building, which is not exactly visible here. So we categorized the point clouds and then we exported them into a mesh in Rhino. So the best thing about Recap Pro was point cloud classification, which is we can segregate the points. Let's say this is land, and here comes into the picture the AI and ML algorithm.
Yes.
So Recap Pro has this mechanism where it can auto identify on its own which are the points of lands, which are the points of trees. So we ran that algorithm, and to some extent we were successful in being able to categorize the points. And after categorization of the points, we exported the surfaces, and how it helped us was, let's say this was one single model. This was not segregated into land, trees and highway and buildings. So once we had that into Rhino, that would be one single model and very heavy to operate. Since it was segregated, our simulation becomes simple. And this is a very small stretch. Just imagine the scale that will be helpful in much larger surveys. So that was the best point about Recap. And then in the last stage, we used with Rhino. But Rhino is optional. We can go for SketchUp or other 3D modeling softwares. This was the render produced on Rhino. And just look at this particular area. This looks like a realistic picture.
Yes.
But this is a mesh exported from Lidar survey. This is a T-junction which students from KGP throng to every evening. And this kind of, so this is where we began with problem identification. Of course, we had a lot of data based on our survey as to the problems that are being faced in this particular area. But then we highlighted all those problems in this particular isometric. And this is not, this is the render from Rhino. This is the point cloud data being exported into the mesh and then being rendered into this model. So, and this on top is the section. So there is a 6 meter level difference from this side is the IIT and this side is the railway station to Kharagpur. There is a 6 meter level drop, and that's accurately captured in this section. We corroborated that data from the Google Earth section which we can create, and of course the NASA data file which we created. So that is accurately captured in this particular section. Now this particular setting for the scan to mesh. Now I mentioned that there are 3 resolutions in which we had the data. One was 0.01, one was 0.05 and one was 0.1. So the different resolutions had different repercussions on the kind of model that we had. Now the model which I exhibit here is not just one resolution. It's not 0.01 and 01 only. It's a mixture of all these things. So we combine all these 3 data points and then we produce the model and then we proceed into the analysis. That was the last step. So then this slide particularly highlights all the different settings that we can have in the export or the mesh preparation. So let's say ma'am was asking what a mesh means. So let's say we have a resolution of 0.01 meter here. This means that the mesh triangles can be around 1 centimeter in size. If we have a smaller number, we have much more detailed data. And if we have bigger number, we are going coarser in the nature of details that we have.
Maybe if they are like sparsely, then
the triangles will be bigger and the details will be not as accurate as they will be in a more dense point cloud. So yeah, this particular image shows you the, this is actually the Cyclone 360 interface. So what I am trying to exhibit here is the nature of precision with which it captures data. this is the station point for LiDAR, and this dark circle which you see is the data which is not collected. But it weaves data as and when it collects it. Once we have collected the data in LiDAR, we go back into the system.
Or from the next point where you locate this instrument, from there also you can capture data of whatever has not been captured.
Yes, it weaves the data all on its own. What happened with our scenario was it misaligned the data. Let's say this was the first point, this was the second point, this was the third point. It mixed it. It said this is the second point, this is the third point, which was not actually the case. So we had to correct that in the software. But then that was so long. And this kind of highlights the station points. So now I'll have a video and it shows the actual data. This image just highlights the accuracy with which it captures data. We don't really see the stitching part. Stitching part is done in the background. As and when it collects data, it populates those points and eventually weaves them together and creates this model. This was the flyover which I was speaking of. And the height to which it can capture data is also relevant here. So what happened was, what we observed was, I mean, in hindsight we found that as the battery of the LiDAR went down, the strength of data collection also kept going down.
Oh, okay.
So this
power is important, power source.
Yes. We kept changing the batteries. I think during the 13 points that we collected, we changed the battery thrice. Since
So the same happens with drone survey. If we do photography, if we do using drone, the drone also is very energy intensive.
exactly. So as and when the battery went down, the strength of data collection went down as well. So this flyover, which is very sparsely populated in terms of the point clouds, would have been much denser had we started with this point. This was not the first point. This is maybe the 7th or 8th point. This point cloud is thin because the battery is down to low. And the issue here is the points close to LiDAR will be dense in number and will be as per the requirement. But as the points are distant and further away, we will face that the number of points are much less in density and number. And this is almost the end of the survey, and this is almost the last point. And what you see is the LiDAR is located this particular region is completely dark because this is much further away, although in the range, in the 45-meter range, but further away from the LiDAR, and so it's completely dark. And these were the challenges which we faced when we went back to the system and wanted to calibrate the model and create a wholesome. So the relevant thing here would be what we did with this data gap. So we did not have points, density of points as in the quantum that we required. So what happened was, this is where the resolution came. For the points which were close by, we could use a smaller resolution, 0.01, 0.05. But for these areas, we had to make do with a much larger resolution. So the ground plane was not as accurate as the reality would be, but then we had to make do with whatever we had. And this is the images that LiDAR captures. This is the 360 degree and 300 degree image, panoramic image which it captures. We can use it for some analysis, of course, but then it's much more relevant in interior spaces, not so much in outdoors. This is the video. This is a video to highlight the nature of data acquisition. This is the video from Autodesk Recap Pro. It kind of goes through the entire stretch in one.
Will it run now?
Yes, ma'am. So this is not exactly a walkthrough. I am just recording this as and when I scroll through the subsequent points of data acquisition. All these circular patches, empty patches, are the points where the LiDAR was located.
this was a part of which subject?
This was planning workshop.
Planning workshop. And was this the first time you were using, or does IIT Kharagpur have this kind of survey? Is having this kind of surveys in the last few years?
No, this was the first time.
First time?
We were the first batch.
You were first batch. And was it very easy to or user friendly, or did you find it very difficult?
No, it was very. The challenge was even the professors had little idea as to
How to go? What exactly?
So
Because it was for the first time.
It was for the first
Maybe if you use it next time, next
Yeah.
it may become.
they have a repository of data from because of us. I mean, we were sitting in the lab for probably 3 days until we figured out how to export points into mesh and then mesh into data and the right kind of software.
Okay.
Recap was not very easy to find, and somehow we.
So
You have laid the path.
now
Later batches but ready.
Maybe you must have given your recommendation that this is more friendly for building analysis or something. Heritage.
Actually, to be very honest, this Lidar was purchased because IIT KGP has, like you said, if an IIT Patna gets a project, we also get, they have a project from ASI for a temple project. So since they have purchased this machine, they wanted to integrate.
What was that project?
It's a temple in I think Vizag or Tamil Nadu. I'm not.
What do they have to do?
They have to. Actually, I have added a video. They have to reconstruct the temple in a 3D model, into a 3D model, and it's a very detailed 3D model. So let's say there is a column, there is a column temple, and column is the temple. So they will create somewhat 16 to 18 surveys to capture the entire column, and then they will populate the data points into 3D and 3D into a mesh, and then that can be used in the future if there is a disaster to reconstruct that column.
So that is basically documentation work they are doing. Huh? Okay. So we have also started with, but then the handicap comes due to unavailability of technology. It's not inavailable. It's a good step. Can we see the other photo, video? You said.
Yes.
This is done. Which baki hai isme?
Almost.
Almost. As a part of photogrammetry workshop which we had in July, we gave a suggestion that our institute should have a laboratory, or in fact full-fledged center, like we have computer center, we can have a photogrammetry center. So there we can suggest to purchase these equipments, or if we get projects, we'll do it under the ambit of that particular center, and then we can have certain equipment purchase which will be retained in those laboratories or centers of laboratories of those centers.
They have an AR/VR lab.
Okay. These we have to actually, we want to come up with.
This is where the survey ends at the other railway line. It starts from one railway line and it ends at the other railway line. That's the end of the spine. This is our professor, a conversation with our professor about what we are doing.
Okay.
And here he highlights.
Who is that professor?
Gaurav Das Mahapatra.
Okay.
He is a new professor. Really. He started with the last batch.
Okay.
Hi sir.
This is the one.
Sir, what are we up to? Yes. What we did. And how much does this machine cost, sir? This machine costs something around 30 to 35 lakhs.
So it's not a very high-end machine.
Can we do
were
something
looking
productive with this for the Indian market?
We were looking
Hi,
for
sir.
machines which was 70-80 lakhs, almost 1 crore.
Exactly.
That is why we hesitated.
So those will be much more powerful than
Yes,
this one
yes.
in terms of data acquisition, point clouds. Since this was not as expensive, the point clouds were not up to the mark. I mean, particularly in the region that we have done. And this was the major learning from this survey, that this is not suitable for
that kind of work.
So for outdoor regions,
Outdoor
particularly,
regions, not-
it is perfect for
For the work that we have discussed,
Yes, ma'am.
maybe
Temple.
some heritage
Yes.
area, some
temple
area.
reconstruction. Yeah, he goes on to mention how.
Okay. Oh, he goes on.
Sir, what are we talking?
Why are people laughing?
This was I was.
Impromptu.
Yes, ma'am. This was very impromptu. I just went up to him and started asking questions.
And how much does this machine cost? This machine costs something around 30 to 35 lakhs in Indian currency. So can we do something productive with this for the Indian market? Yes, we can do. We can start mapping the heritage buildings and also the different urban areas. And we can create any proposals. Right. So are we using this for any proposals as of now? Yes, presently we have submitted one proposal to ASI and we are trying to map the historic buildings so that if in future it gets destroyed also, the 1:1 scale model will help us to restore it, that is create the proposals. And also we can create VR models with this so that the people who cannot come to the heritage sites can sit in their homes and enjoy have a real-time understanding of the heritage structures. This is one way. Another way is the mapping, which we are doing right now. So we can give realistic proposals to the city council. So sir, is KGT the only college working on such a project? No. KGT is not the only college. Many colleges are working, but our research methodology is unique. Right.
This particular map kind of goes on to depict the interior of data acquisition. This could be created from GIS using satellites from data from satellite, but this is based on the data acquired from the Lidar, and then we corroborated that with the data from satellite as well. But then we kind of merged the two data points together, and then this map particularly was created. And then subsequently our proposal, which I have not covered in this presentation, our proposal kind of the thrust of the proposal was prevention of flood, because one of the major issues faced by this particular spine, this commercial spine, was that flooding at 2 points. So we kind of modeled the whole area on Rhino, and then we simulated the floods.
So your faculty was aware as to how to use it and how to promote, or not?
And he was also
Not so well. So once you guys used, and then he probably went to that building and gave that proposal to SI, was it?
probably, ma'am, because we received no help in terms of how to populate the mesh into data into. Probably he did not need that from his end. Maybe that could be the case, but then we received no help in terms of the softwares which we should go for to acquire the data and populate it. And these were the major gaps and learning. So one point which I missed was, let's say, I have stationed the satellite at this point, and this chair will be covered in the model, but then behind this. Or let's say we were performing the survey in broad daylight and there was harsh sun. So let's say I am standing there and the sun casts a shadow behind me. That point will not be captured.
Okay.
So shadows were.
We could see shadows.
Yes, exactly. So
Near the Vadilal center.
Yes.
But can we use in the darkness artificial light or something?
yes, of course we can use, but then the strength of the light really matters. We did an indoor survey for the IIT atrium, the architecture department atrium, and it captured data accurately, but then there were skylights in the building, so a lot of natural light was coming in.
Yes.
A completely artificial light environment was not.
Okay, so you have to have strong lights if you have to do
We have to have strong lights because
And you have to maintain the direction of the sunlight and all. Because of shadow of tree
yes,
and
yes, yes. You have to keep that in mind that there should be no shadows
So
in the
you
area.
have to maintain that which time you are going to capture the data.
If it's possible for you to manage a survey without shadows, that will be the best thing. But
Because it depends on planning, like when we are going to survey.
if you can minimize the shadows, that will be the best thing, because otherwise we miss out on data points. Subsequently, the mesh that you create from it. And this, So yeah, the sequence mismatch. So Lidar in and of itself proved to be not so efficient in terms of sequencing the data, like this is point 1, this is point 2, this is point 3. When we go back into the system, we find that it has mixed the numbers.
Oh.
This is point 2, this is point 1, and this is point 3. So then that was the stitching part which we had to take care of in the Cyclone 360. And
Another software.
that is the software which comes with the Lidar, Cyclone 360. And that was one of the major limitations, man, because uska crack nahi hota hai.
Oh.
That's only one software which we had, so we had to sit in the lab particularly for that. And we were learning on the go how to create the mathematical overlap.
Exactly.
And there was this method. As I told you, we need a 90% overlap. But then we were not able to achieve the 90% overlap because of the absence of data, a dearth of points. So what we figured out was we can lower the metrics. In the software we can override the system and we can lower the metrics. We then do not need the 90% overlap. We can kind of find our way around that 90% benchmark, and that's what we did. But eventually, because we did not have the point cloud to have that 90% overlap, and so we lowered the metrics and the resolution was achieved through that manipulation.
If we have to go for documentation and if we do not have the equipment, maybe we can hire from some organization that
Do that.
either produces it or who sell it. Maybe we can have certain tie-up with those, they can give us on rent, maybe this.
Ma'am, in Bihar also the land surveys they did. I think there were 3 firms, 2 from Delhi and 1 in I think Bihar itself, who were employed for this particular aerial survey of the entire. So ma'am, wo abhi aajkal jo zameen ka chal raha hai, that was from 3 firms, 2 in Delhi and 1 in Bihar. So they are involved in this business. And I'm pretty sure they have some.
Okay. So I had not given an introduction of Raj. Basically, he is one of our own students of bachelor's. Now he is doing masters at IIT Kharagpur. He was in 2018 batch. He passed in 23. He passed in 2023, and he joined Kharagpur this year, 2025. And right from the beginning, he started using this one, Lidar survey.
Ma'am, this was the 3rd assignment. Prior to this, we had 3 ones.
What was this?
First was, ma'am, introduction to a city. We had to introduce a city. And then the second one was preparation for an action plan for another city of your choice. And then this was the 3rd one where we had to go to a survey. And then the 4th one was where we...
So we have to incorporate your lectures in programs like this. So this is one thing we are very happy for the work Raj is doing. So Shiva, please the moment.
A very warm welcome to the valedictory session of the Gyan course on Architectural Heritage Management and Heritage Conservation on Post-Colonial Buildings in India, organized by the Department of Architecture and Planning at IIT Patna. This course has been a part of our ongoing efforts to explore how modern technology can aid in preserving the timeless beauty of our built heritage, and we are truly delighted to have seen such enthusiastic participation. Today, as we draw this enriching journey to a close, we take a moment to reflect on the insights gained and express our heartfelt gratitude to all those who made this course a success. This program has helped us look at India's post-colonial architectural legacy with a renewed sense of responsibility, from the challenges of conserving exposed concrete and modern materials to the use of advanced tools such as digital documentation, mobile-based solutions, and Lidar scanning. The sessions have broadened our understanding on how heritage can be managed with both sensitivity and innovation. We have explored case studies from India and across the world, understood global conservation practices, listing processes, and discussed the significance of young timers as an essential part of our cultural identity. The insights shared here will undoubtedly influence the way we perceive, document, and preserve our architectural heritage in the years ahead. From insightful lectures to hands-on sessions, from intricate technicalities to the emotion behind conserving heritage, this workshop has truly been a beautiful confluence of tradition and technology. On behalf of our organizing team, I would like to extend sincere thanks to our distinguished speakers whose knowledge and guidance were truly invaluable. Over the past few days, we have had the privilege to learn from leading experts, Professor Carl Zanglin and Professor Ajay Kare, who took out their valuable time and shared their insights and inspiring perspective with us. We are truly grateful to both of them. Their presence has enriched this course and given us new ways to think, question, and learn. We are also deeply grateful to all our participants for their active involvement and enthusiastic engagement throughout the workshop. We hope that the knowledge you have gained will contribute meaningfully to your academic growth and professional journey, especially in the field of heritage documentation and conservation. We would also like to acknowledge the efforts of our volunteers and organizing committee members who worked behind the scenes to ensure everything ran smoothly. Now we move to the distributing certificates to all our participants.
हाँ अच्छा बस ठीक है
किसका फोन है? शिव टेबल प्लीज देखो।
मैं यहाँ पे यहाँ पे मैम नहीं भैया
You made this program lively.
Hello, Ranjan. अतुल, ललित,
नहीं,
संदीप,
इन सबका एग्जाम है आज। एग्जाम है सबका आज। शाहिद इज हियर? नहीं, उसका heritage coordinators, they are MURP third semester. So they work दिन रात जो मुझे बोला गया ये लोग किए, and we are actually very proud. Just cover my left and right hands.
Rahul Kumar.
Rahul.
मैम यहाँ सभी लोग सामने में